Okay, good morning or good afternoon if you are my sixth period class. This is Mr. White speaking to you. I just wanted to let you know that my baby girl was born. Her name is Amelia Charlotte White. She was born at 10:53 a.m. on Friday. So I have taken the weekend. I'm going to take today to spend time with my family, and I will be back with you all tomorrow. In the meantime, I created this screencast so you guys can practice on experimental design for the scientific method. So today you'll be doing practices with the screencast. You have a sheet in front of you. We'll be practicing there. And tomorrow, when I come back, you'll be doing an artifact related to experimental design and the scientific method. All right. What is experimental design, you wonder? Basically, experimental design is how you decide what you are testing and how you will measure it while limiting bias and following ethical guidelines. Remember, we talked about this on Thursday. We talked about how there is no set method to the scientific method. But if you are going to do an experiment, there are things that should be in your design of any experiment you should do. The order you do it in, of course, depending on the science you do it, will all be different. But the base experimental design will all be here for you today. So, some important terms for experimental design. I gave you an example of a hypothesis, and most hypotheses are written in an if-then statement. So in this hypothesis, I wrote, if I raise the temperature of a cup of water, then the amount of sugar that can be dissolved in it will be increased. All right. So you have three variables in every single experiment. You have the independent variable. This is the one factor that you change in an experiment. Notice how it's in bold. You are only allowed to change one variable at a time. A lot of you on your science pretest put you can test variables at a time. You can test 5, but you have to do 5 different experiments for every variable. I repeat, you are only allowed to change one variable at a time. In the case of the hypothesis, I am going to change the temperature of the water. Everything else will remain the same, and we'll cover that in a second. So if you notice in the hypothesis, if you notice right here, I have it in red. If I raise the temperature of the cup of water, that is the one variable I am changing. I am changing the temperature of the water. All right, the next variable is a dependent variable. This is the variable that is a result of something changed. So in this case, I am changing the temperature of the water, and the variable that's going to be affected by that is going to be amount of sugar that will dissolve based on the temperature will increase. Notice that the dependent variable is in blue for you, match with the definition. The third factor is the controlled variable. These are the variables that will stay the same. In this example, the cup of sugar will be the same, 2 tablespoons. You can do 3 tablespoons, you can do 4 tablespoons, but that has to be the same for all of your tests. The type of cup I'm going to use, it has to be the exact same cup. If I'm going to use a mug, I'm going to use the same exact mug. If I'm going to use a glass, I'm going to use the same exact glass. And the amount of water will be the same. If in this case, I'm using a cup of water, so the cup of water has to be the same. So in this case, if I were to change one of my independent variables, everything else has to be controlled and stay the same. What I want, Mr. Sub or Mrs. Sub, what I want you to do is I want you to pause this video, have the students talk to each other, and ask them how many variables they are allowed to change at a time. Okay. If you answered one variable, you are absolutely correct. Keep that in mind. You're only allowed to change one at a time. All right. There are types of groups that are in experimental design. You have the test / the experimental group. These are the groups that are being tested on. These are groups you're doing the test on. And you have the control group. This is the group where no changes are being made. Typically, there are one control group, but as you get more advanced into doing experimental design, you can have more than one control group. But just for this case, typically there's only one control group, and every other group is the experimental group. Okay. The point of having two different groups is we compare the control group to the experimental group. That's where we get our results from. If the experimental group is different from the control group, we have to determine what was the factor that changed it. And in this case, the variable / the factor that changed was the independent variable. That's why we do this. All right. Now, what I want you guys to do, I want you to look at your practice sheets and make sure you are on the side that says B experiment. I'll give you a second, make sure you're on the right side. Check your neighbor next to you, make sure they're on the right side. All right. Can we please have a volunteer in the class read the description right above the table? Okay. Thank you for reading that for me. Now take a look at the table. As you are looking at this table, I want you to answer the following questions. How many groups are there? Talk to your table mates about this. What are the type of bees being used? The type of day or the time of the day? That's not supposed to say type, that's supposed to say time of day. Sorry. The type of plants being used. And finally, the flower color. What are the color of the flower? All right, last question. Which variables are the controlled variables and which variables are the independent? Which variable is independent? So which variables are controlled? Remember what controlled means. I will go back to that slide so you guys know what I'm talking about. Controlled, remember, these are the variables that will stay the same. And the independent variables in this case are the ones that you change one. So which variable is the independent variable and which variable is the control? Which variables are the controlled variables? All right, talk to your table about that. Please pause the video and let them discuss it. All right, I hope you are able to answer all the questions. To make your life easier, what I want you guys to do, I'm going to flip screens here. All right, this is your paper in front of you. What I want you guys to do is to label on the top here. I want you guys to write C for controlled. So if this is control, you write a letter C right here. Or I for independent. And the chart's right here. Okay. What I want you guys to do for the next 5 minutes, I want you guys to work as a table group and answer questions 1 through 5 on this side. Please pause the video and let them work on side 1. Okay, welcome back. I hope you guys were able to answer this pretty easily. Let's take a look at your answers. All right, answers to questions 1 through 5. Number 1, what factor is the independent variable in this experiment? The correct answer is D, the color of the flower, because that is the one variable that is changed in this experiment. Number 2, a credible, trustworthy experiment tests how many independent variables at a time. Think about independent variables. You are only allowed to change how many at a time? The correct answer is 1. That is D for 1. Number 3, which of the following hypotheses could be tested by this experiment? Now we take a look at this chart and we notice that all the flower colors are different. So looking at the 4 answers, the best answer was B. Honeybees prefer to visit the red flowers. That is our hypothesis we are going to be testing. Number 4, which of the following is the best reason why the Portland rose is included in all of the groups to be studied? And the correct answer is A. A type of plant is a controlled variable. Any type of flowering plant could have been used if all the plants are the same. So in this case, you could have used a rose, but make sure that all of the groups are roses. You could have used a sunflower as long as they're all the same. It is a controlled variable. Remember, controlled variables are the variables that stay the same. Number 5 on your paper, and unfortunately says number 3. That is a typo. Making sure the bees in the experiment are not harmed is a part of, the correct answer is ethics. Hopefully you all got that all right. All right. What I want you guys to do, just to see, I want you guys to write the number out of 5 you got correct. Remember, this is not for a grade. This is just a practice run to see how well you know it. Tomorrow's artifact will be determining to see how well you know it. And when you're done writing that out of 5, please flip your paper over to the other side. All right. What I want you guys to do is I want you guys to read the following experimental designs and answer the questions that follow. So you guys, everybody should be on. Everyone should be on this side right here. If you take a look, everybody should be here. Mine is in color. Yours is in black and white, but you guys still get the idea. All right. What I want someone to do, please someone read the hypothesis, the if-then statement right here. Someone please read that. Thank you for reading that. All right. What I want you guys to do in your groups, in your table groups, I want you to go through and answer questions 1 through 5. Only do experiment 1. Do not go on to experiment 2. We want to make sure that you're all understanding this and getting this right. Number 1, what is the independent variable being tested in the experiment? Before I go on, before you guys answer, I'm going to put up that original slide to help you guys guide you. All right. Number 2, what is a dependent variable in this experiment? Number 3, what other controlled variables in this experiment? A hint for that one, there are 4 of them. Make sure you have all 4. Number 4, which groups are the testing/experimental groups? What groups? And number 5, which group is the control group? Remember, here's a hint for you. For number 5, there is 1 answer. And obviously for number 4, there are 3. So make sure that you look at what the control means. Take a minute, talk to your team. I'm going to go back in the meantime and pull up that slide for you so you can use that as a guide. Go ahead and start working. Teacher, please pause the video and leave this slide up for the students to use as a guide. Thank you. And remember, only do experiment number 1. All right. Hopefully you all had a easier time doing this. Again, this is just a practice run. We will get better at this. Let's take a look at your answers for numbers 1 through 5. Make sure we get there. We got to click through all this again because I want to make sure you guys had this. This is from the last page. All right, here we go. Question number 1. What was the independent variable being tested in the experiment? The correct answer is the amount of sunlight. If you take a look at all of the group, if you look at the sunlight, group 1 is 2 hours, group 2 is 6 hours, group 3 is 10 hours, and group 4 is 0 hours. So that is the one variable that is changed in this experiment, the amount of sunlight. And because of the amount of sunlight being changed, what is the dependent variable in this experiment? In this case, the dependent variable is going to be the growth of the plant. I'm going to go back for a second because I want to show you guys a trick to figure out independent and dependent variables. Oh, went too far. All right, here we go. If you take a look at this hypothesis right here, if I raise the temperature of the cup, then the amount of sugar that can be dissolved in it will be increased. The independent variable in this case is always the first part, is the if statement. The then statement is the dependent variable. So in the next time you read that, if you read if then statement, if is always independent and then is always dependent. So keep that in mind. All right. Let's go back to our questions, our answers. All right. Number 3. What is the control variables in this experiment? I hope you were able to find all 4. In this case, it is the amount of water. It's 1,000 milliliters of water being poured in. The type of plant. If you looked at the picture, all the plants are the same. The size of the plant. All 4 plants are the exact same size. And the size of the plant container. If you take a look at the picture, those are the 4 factors that are all the same. How many of you were able to get all 4 of those? If you didn't get all 4, try again next time. Question number 4. What groups are the testing experimental groups? The correct answer is groups 1, 2, and 3. If you take a look, those all have different hours of sunlight. We are trying to determine which the plant that receives more sunlight should grow taller. So question 5, which group is a control group? Remember, the control group is a group we do nothing to it. The correct answer is group number 4. All right. What I will let you guys do is I want you guys to do experiment number 2 and do it as a table, and we will come back. Let's take a look at these answers again. Same thing. Someone please read the if-then statement about mice. Scroll down. Read the statement right here. Thank you for reading that. All right, what I want you guys to do, same thing at the table, look at the experiment and answers questions 1 through 5. Again, I will put up the definitions of independent, dependent variable as your guide. Talk at the table. I'll give you guys about 5 minutes to answer these questions as I put the guide for you up. Oh, went too far. Teacher, please pause the video and leave up this slide so the students can use this as their guide for answering questions for experiment number 2. All right, welcome back. Hope you've had an easier time doing this. All right, so let's take a look at the answers for experiment number 2. We got to get there first. All right, experiment 2. What was the independent variable being tested in this experiment? If you take a look at the hypothesis, the experiment in this case is the pigment color. If mice with pigment color can absorb calcium better with mice without pigment, then the dependent variable will be the pigmented mice should have higher levels of calcium. Correct answer. Number 2 is the levels of calcium. Number 3, what is the controlled variable in this experiment? I hope you're able to get all 4 of them again. The correct answer is the breed of the mouse, the amount of calcium, the age of the mouse, and the gender of the mouse. If you take a look, the age is they're all 3 weeks old, and the gender is they're all males. And the breeds, they all look the same, and the amount of calcium they got put in them is 0.5 milliliters. Question number 4. What groups are the testing experimental groups? The correct answer is groups 2, 3, and 4. And if you take a group number 1, the only difference with group number 1 is the number 1 has no pigment. They have no color. So the correct answer, number 5, the control group is group 1. All right. That is the end of my experimental design lesson. I will have this PowerPoint I'm showing you guys up on Google Classroom. I will also put this screencast on Google Classroom if you want to view this as a study guide. All right. Thank you very much. You guys have a great rest of your day, and I will see you all tomorrow. Have a great day.